Let me repeat it. Object is always placed left to the mirror, and all distances are measured from the pole of the mirror, and the distances measured right side the mirror is taken as positive, distances measured left side of the mirror is taken as negative, and distances above the principal axis, that is height above the principal axis, is measured as positive, and the height below the principal axis is measured as negative. So I'll repeat it once again, because these are very important while solving the numericals. So always remember, object should be taken as left side of the mirror, and distances are measured from pole of the mirror. The distances measured right side of the mirror is taken as positive, distances measured left side of the mirror is taken as negative, height above the principal axis is considered as positive, height below the principal axis is taken as negative. So u is the object distance, v is the image distance. Okay, so object distance u is always negative. So when u is always negative, why u is always negative? Because object is always left side, because the distances are measured from pole towards the that is against the incident ray is taken as negative. So remember, object distance is always negative. So focal length of concave mirror is negative. Why focal length of concave mirror is negative? So because see, if this is a concave mirror, the rays after reflection, they will meet at one point. This point, this specific point on the principal axis, we call it as principal focus. So the distance between the focus and the pole, that is this distance, we call it as focal length. So focal length of concave mirror is negative. Reason is all distances are measured from pole, so the distances measured left side the pole is taken as negative. So that is why focal length of concave mirror is negative. So the focal length of convex mirror will be positive, because the concave mirror, that is the convex mirror is having virtual focus. I have already said you while explaining the difference between concave mirror and convex mirror. Concave mirror will have real focus, so that is why the focal length of the concave mirror is negative, whereas the convex mirror will have virtual focus. Let me show it. So if this is the principal axis, one ray will go like this, one ray will diverge like this. So if you draw these rays backwards, they will meet at this point. So this is called focus. The distance between this point and pole, we call it as focal length. Okay, so here the distances is measured is from the pole. Okay, we are measuring it towards the right side, so that is along the direction of incident ray. So that is why in the case of convex mirror, the focal length will be always positive. Okay, remember this. The focal length in the case of concave mirror is negative, the focal length in the case of convex mirror is positive. Okay, let us move on to the next topic, that is mirror formula. So based on this formula, you will be solving many problems, like find the focal length of a mirror, find the object distance, or find the image distance. Like these questions will be asked in exam, so you need to know what is mirror formula. So in the case of mirror formula, it says that is 1 by v plus 1 by u is equal to 1 by f, or you can say 1 by f is equal to 1 by v plus 1 by u. So this is the expression for mirror. Okay, while solving the problems, you can use this formula, where v is the image distance, u is the object distance, f is the focal length. Okay, so next we will move on to the magnification of spherical mirror. Okay, magnification of spherical mirror. What is magnification? You might have heard like magnified image, or like these words you might have heard. Okay, so we will see what is magnification. So magnification means it is the ratio of height of the image to the height of the object. So height of the image is hi, height of the object is ho. So the ratio of height of the image to the height of the object, that is m is equal to hi divided by ho. So this is what we call it as magnification. So it is very simple. The ratio of height of the image to the height of the object, we call it as magnification, or you can say m is equal to minus v divided by u, where v is the image distance, u is the object distance. So you can define it as the ratio of the image distance to the object distance. We can also call it as magnification. Okay, so here in the case of magnification of mirrors, m is equal to hi divided by ho, that is equal to minus v divided by u. So this is the expression for magnification in the case of mirrors. Okay, is it clear? So what does negative and positive symbol in the magnification formula indicates? So we will see. If m is negative, that is m is equal to minus v by u. Okay, in some problem, if they mention m is equal to minus 2, or magnification is equal to minus 4, or magnification is equal to plus 5, or magnification is equal to plus 7. Okay, what does it mean? So that is what we are going to discuss next. If m is negative, the image is real. If m is negative, the image is real. If the image is real, it is always inverted. So remember, if m is negative, the image is always real and inverted. If m is positive, it is always virtual and erect. Okay, so how you are going to say based on this negative and positive? Okay, so let me explain. If hi, that is height of the image, is equal to height of the object, then m will be equal to 1, right? That is from this equation, that is if m is equal to 1. So first case, let me explain the first case. If hi is equal to h naught, then m is equal to 1. So that is from this equation, if m is equal to 1, then 1 is equal to hi divided by ho. Therefore therefore hi will be equal to ho. Okay, that means image height will be equal to object height. Clear? So if m is greater than 1, for example, let me take m as 2. So 2 will be equal to hi divided by ho. So 2 times ho will be equal to hi, correct? So what happens? Hi, that is height of image, will be equal to 2 times the height of the object. So if m is greater than 1, that indicates hi is greater than ho. So image is enlarged, that is 2 times, depends on the magnification, but I can say is image is enlarged. So next one, that is if hi is less than h naught, that is if m is less than 1, let me take it as 0.5 or half. So half is equal to, I am taking m as half, so hi divided by ho. Okay, ho will come this side, ho is equal to 2 times hi. Okay, so you can see clearly here. So the size of object is 2 times the size of the image, that means image is diminished. Clear? So this is what the explanation of positive, negative, and if m is equal to 1, if m is greater than 1, if m is less than 1, what will happen? Okay, so if m is negative, if magnification is negative, image is always real and inverted. If magnification is positive, image is always virtual and erect. If magnification is 1, then height of the image is always equal to height of the object. If magnification is greater than 1, then height of the image is greater than height of the object. If magnification is less than 1, then height of the image is less than height of the object. Clear? So since height of the image is less than height of the object, image is diminished. So in the case of plane mirror, okay, so next is magnification of plane mirror. So magnification of plane mirror is always plus 1. So why, how it is plus 1? How magnification in the case of plane mirror is plus 1? Let me explain. See, I am taking a mirror. Okay, this is a mirror. I am standing here. So distance from object to the mirror is 10 centimeter. Of course it is a plane mirror, so image will be formed exactly at the same distance, that is also 10. In the case of plane mirror, height of the object will be same as height of the image. I will take it as 5 centimeter height. Here also I will take it as 5 centimeter. So from the formula of magnification in the case of mirror, we have m is equal to hi divided by ho is equal to minus v divided by u. Okay, so substituting the value of this, what is hi? 5 centimeter. Since it is above the principal axis, I will take it as 5 only. Here ho, again it is erect, it is above the principal axis, I will take it as 5 only. So 5 cancels, magnification will be 1, that is plus 1. So if magnification is plus 1, that is positive, the image is virtual and erect. So you can see clearly the whatever the image in the case of plane mirror is virtual and erect. Or else you can take object distance as well as image distance. So if you take object distance as well as image distance, what will happen? So from the magnification formula, we have m is equal to minus v divided by u, correct? So m is equal to minus, what is v here? So since it is right side, it is taken as positive, so minus of 10 divided by u, it is left side, you have to take it as negative. So minus of object distance is how much? 10. So 10 minus minus cancels, 10 cancels. So magnification of plane mirror is always plus 1. So plus sign indicates that image formed in the case of plane mirror is always virtual and erect. So and if it is equal to 1, if that is that magnification of plane mirror is equal to 1, means the size of the image is always equal to size of the object. If m is positive and less than 1, it is convex mirror. If m is positive and more than 1, it is concave mirror. If m is negative, it is concave mirror. So these are the things you need to remember while solving the problems. Clear?